So we are now in the chapter 5, which is the vertical stresses in soils, which is part now of the final term topics. So we have this topic outline. First is we'll discuss the in situ stresses in soil, stresses in saturated soil without seepage, stresses in saturated soil upward and downward seepage force, capillarity of soils, and effective stress of soils in the zone of capillary rise. For intended learning outcomes, you have to you will be able to explain the effective stress principles, identify the difference between total stress and effective stress, calculated the effective stress as influenced by water and seepage and in the zone of capillary rise, and then calculated the seepage force. So I've already posted other videos, lecture videos from the YouTube, so that you'll have advanced knowledge. And also this one, I also posted this one for you to have advanced study of this topic. For the introduction, the nature of stresses along given cross-section of the soil profile is the key to analyzing the compressibility of soils, bearing capacity of foundations, stability of embankments, and lateral earth pressure on earth retaining structure. So to be able to understand why is this happening like this one, there is this erosion of side of the, think this is bridge or a road, and also to be able to understand why this pisa is leaning towards the right. No, the study of this topic, the stresses of soil, is so that you'll have knowledge how this nganong nahitabo ni siya, this leaning tower of Pisa. Maybe the soil in this portion is more compressible, or how to say, ni-settle siya, ni-settle siya because of the properties of the soil, which is more compressible than the other side, Soil is a multi-phase system. To perform any kind of analysis, we must understand the stress distribution in the soil. So we have the concept of this effective stress. The effective stress concept, if the soil is loaded, footing for example, the resulting stress is transmitted to the soil mass. The soil mass supports those stresses at the point-to-point contacts of the individual soil grains. So if you have the footing, then this part here of the soil will have the stress and will have the upward force that will support the foundation or the footing. So we have stresses at a point in a soil mass are divided into two main types. We have the geostatic stresses, which is due to the self-weight of the soil mass, and the excess stresses, which is from the structures. So geostatic stresses itself, no? Self weight of the soil mass. So, katong unit weight, no? Unit weight times the height of the soil mass, that is geostatic stresses, while the excess stresses, which is from the structure, no? Or if there is footing, then you have this, will have excess stresses. Under the geostatic stresses, we have the vertical stress. Vertical geostatic stresses increase with depth, no? Remember this one, vertical geostatic stresses increase with depth. There are three types of geostatic stresses. So this one, we're going to study these three types of geostatic stress. We have the total stress, the effective stress, and the pore water pressure, denoted as small u. The total stress is actually equal to the effective stress plus the pore water pressure, expressed in this equation, no? We have the total stress is equal to the effective stress plus the pore water pressure. So in this figure, you have here the water table, which is over the soil mass, no? There is height of the, from the soil to the water table is h, and under this portion, or this a, there is this a, that is the height from the water table is ha, no? So this, there is, because naa may water dire, there is what we call the pore water nga musuksok sa voids of the soil, no? And this is the soil particle. So that the total stress, no, is actually equal to the height, that is h, times the unit weight of the water, that is denoted as gamma w, gamma sub w, plus ha, this is ha to this. If you want to get the total pressure at point A, now this is the formula or the equation, plus, no, so naa na kay kani nga stress, no, due to water table above, plus the total stress of this portion of the soil, no? We have h sub a minus h times the gamma saturated, no? Saturated unit weight of the soil at this portion. Saturated siya because there is water naman, no? May water sa ibabaw, so meaning there is a saturation of the soil, where our sigma is equal to the total stress at the elevation of point A. So this is the point A. Then gamma sub W, this is the unit weight of the water. Gamma sat, this is the saturated unit weight of the soil. H is the height of the water table from the top of the soil column, this one, no? And H sub A is the distance between the point A and the water table, no? This is water table until point A. So what is the total stress at this point A? So this is the formula, no? To further understand this one, we have series of slides, no? Total versus effective stress. So when a load is applied to soil, it is carried by the water in the pores as well as the solid grains. So the increase in pressure within the pore water causes drainage or flow out of the soil, and the load is transferred to the soil grains. The rate of drainage depends on the permeability of the soil. The strength and compressibility of the soil depend on the stresses within the solid granular fabric. These are called the effective stresses. So the concept of this effective stress is that you have the total stress. This is the combination actually of the soil soil mass nga unit weight plus the water, no? Because from this statement, no, when load is applied to soil, it is carried by both water, no, by both water and the solid grains. So kung walaon nimo ang water or the pore water, kung increase nimo ang pressure, meaning increase nimo ang load, tendency ana mo drain ang tubig, causes water to drain, no, or flow out of the soil. So manang the load will be transferred to the soil grains, no. That is what we call the effective stress, no. The total stress is equal to the stress of the soil minus the pore water stress caused by water. For the effective stress, stress is the sigma, is sigma, or this is actually, yes, sigma. Stress is the, sigma is the stress applied to the soil by its own weight. As you go deeper in the soil mass, the stress increases. Now, like in a swimming pool, as you go deeper, the stress of the soil of the water remains. The soil carries the stress in two ways. We have a portion is carried by the water, acts equally in all direction, and the portion is carried by the soil solids at their point of contact. So actually, the effective stress is the stress of the soil, no, nga naay water. Then, increasing that pressure, tendency mo drain ang tubig, ang nabilin is actually ang kato na lang soil ang mo carry. So that is actually the effective stress, no? Because the total stress is, as we discussed, because the total stress is equal to the effective stress plus the pore water pressure. So if you try to find the effective stress in this concept, in this formula, this is the total stress minus the pore water pressure, no? So, the sum of the vertical components of the forces at their points of contact per unit of cross-sectional area is the effective stress. So, if this is the cross-sectional area, so actually the effective stress is the sum of the vertical components of the forces at their point of contact. We have this vertical stress due to overburden. In a dry soil mass having a unit weight of gamma, the normal vertical stress at depth of h is simply, if you have the unit weight of the soil, the stress at x is actually simply equal to gamma, the unit weight, times this height. If there is a uniform surcharge Q, if there is surcharge Q, na kay surcharge diri nga, which is a unit in pressure, Q. So, placed at the ground level, this stress becomes the gamma times the height, which is due to the at x, at x. What is the total stress at x? So that is gamma times height plus this surcharge Q, Kung naakay, say we have surcharge, meaning you have additional load at the ground level, meaning, for example, naakay footing, So, pressure of that surcharge pressure plus the stress at certain point. So, that is the total stress at x, We have this, to better understand the effective stress. Vertical normal stress is due to overburden in dry layered soil. So, what is the vertical normal stress at x, In a soil mass with 3 different soil layers as shown above, the vertical normal stress at x is actually equal to this stress at soil 1 is actually equal to the unit weight of soil 1 times the height plus the unit weight of soil 2 plus the height plus at tama naman ka x, and this is given h sub 3, no? At soil 3, so that the stress at this portion, at this soil 3 is gamma sub 3 times h sub 3. So that is the total, no, stress at x, vertical stress at x. Vertical stress in saturated soil mass due to overburden. So, for example, we have here a soil mass, then naa siya tubig, no? This means na ay tubig diri, kaninga symbol. Na ay tubig diri. Then what is the stress at x? So, the total vertical normal stress at x is given by, say we have given gamma saturated, no, of the soil. So, the total stress is actually equal to gamma sat times h, no, height. And the pore water pressure at this point is simply, because naman kay tubig diri, no, you have here the water. This is, so the stress at x, no, the pore water pressure at point x is equal to U, is equal to the unit weight of water times the height. Therefore, the effective vertical normal stress is actually equal to total stress minus the pore water pressure, as discussed earlier in the earlier slides, earlier slide. The total total stress is actually equal to the effective stress plus the pore water pressure. So, kung imo ni siyang manipulate, the effective stress is actually equal to the total stress minus the pore water pressure. Bali nimo ang U diri, no? So that the effective stress, which happens in here, diba? The effective stress is equal to the total stress minus the pore water pressure, no? So meaning, this is the effective stress that the soil mass will carry itself. Will carry the load. Effective stress is the soil will carry will carry itself, no? Will carry in his own particle. We have the computation of the effective stress. We have the method 1, no? Actually, there are two methods. Method 1 and method 2 that is presented in here. So, what is the vertical stress at point A? We are now targeting the vertical stress at point A. So, for method 1, yung gibuhat is the summation of stress, ato sang sabton ang figure, no? You have here different layer of soil. We have the this type of soil has the unit weight of gamma sub 1, no? And this part of, actually pareha rin ni siya nga soil. The difference is that naay water table diri dapit. So naa kay water table. Na kay water diri, while diri is wala pa. But the same unit weight, which is gamma sub 2. So meaning, the same soil ra ni siyang duha. And this portion here, the type of soil that has a gamma sub 3 unit weight. So what is the total vertical stress or effective stress at point A? So first is, gibuhat sa method 1 is, he computed the total vertical stress. So given as gamma sub 1 times 3, which is, this is the height, no? The height of this kind of soil, plus gamma sub 2 times 1 plus 1, which is 2, no? Times the height 2, plus gamma sub 3 times 3. Where G sub I is the depth of the layer I. So this is the expression represented by this, no? From the figure. So if given the gamma sub 1 is equal to 16 kilonewton per cubic meter, gamma sub 2 is equal to 19 kilonewton per cubic meter and gamma sub 3 is equal to 17 kilonewton per cubic meter, then you only have to substitute the values of gamma 1, gamma 2, and gamma sub 3. So that the total stress is equal to 137 kPa, kilonewton per cubic. kPa. This is stress naman siya, no? This should be squared, not cube. This should be negative 2, no? Raised to the power of negative 2. Then deduct the buoyant effect of water. So this is the pore water pressure, no? Remember that ang imong water table is naa diri, somewhere here. Nakay tubig diri. So meaning, nakay pore water pressure at this portion, no? So the pore water pressure, the effect of water is actually equal to the unit weight of the water times 4 unit, no? Or 4 meters, which is 1 plus 3, no? Okay, we are after of the effective stress at A. So that the answer is, if the unit weight of water is given as 10 kilonewton per cubic meter, so times 4 meters, so the answer is 40 kPa. And remember that the effective stress is equal to this equation from total stress is equal to effective stress plus U, no? If you want to manipulate this, so mahimo ni siya gani. So that the effective stress at point A is actually equal to the total stress which we computed minus the pore water pressure, no? The effect of water. So this is the answer for the total effective stress at A. How about this method 1, no? How about method 2? Unsa iyang gibuhat? So the same figure and the same given, no? The same given of the unit weights of different type of soil. But minus na niya daan ang pore water pressure, ang effect of water. Remember that the effect of water is kaning portion sa gamma sub 2 at half of this one and gamma sub 3 na akay water diri. So yung gibuhat is 16 times 3, which is layer 1, this one, no? This is the unit weight. This one is the unit weight. This is gamma 1. 16, no? 16 kilonewton per cubic meter times 3, which is height, plus 1 times gamma sub 2. No, this 19 kilonewton is gamma sub 2 as given before, no? Given in the earlier slide, this one, no? We have here these values. The same values there is a method 2. Plus times 1. This one is the height. Nga naanay water. Naanay table diri, di ba? Water table diri. Naanay kay water diri. So 1 times the unit weight of the soil at this soil minus the unit weight of the water, no? This is actually the unit weight of the water. This is unit weight 3, no? Plus again 3 for this type of soil. Kani siya 3 height, no? Times the unit weight, this is gamma sub 2 di ini 19 because mo man siya parehara man ni nga type of soil, so that is gamma sub 2 not gamma sub 3. And here this time this is gamma sub 3. Now kani 3 minus the unit weight of the water, gamma sub W, kay na magkay tubig pa diri. This portion kani, this is included in the effect of the pore water, no? So that the same answer actually siya, no? So kaning 19 minus 10, this is the submerged unit weight of layer 2, or that is gamma sub 2 prime. The answer for this one is 97 kPa, which is the same as before the computation in method 1 kani siya. So actually pareha na siya. Then we proceed, no? We have here, I think this is question, or example, the soil profile shown in the figure consists of two soil layers with different dry densities. The average degree of saturation of soil is 30%. The water table is at 2-meter depth. Assume that the specific gravity is equal to 2.7 for both soils. Calculate the following values for both soils. So, okay, right, the computation. So to answer this one, we have this concept. Now, the effective stress controls the deformation of the soil. It is defined as difference of total stress and the pore water pressure. So this one, this is the concept now of the effective stress. The effective stress, total stress at P. Okay, to answer this one, total stress at vertical stress at P. Now, this is the calculate the following values for both soils. So, total vertical stress at point P. This is point P. This portion here. And O. This is point O. And calculate also the pore water pressure U at, P and O. And calculate the effective stress at P and O. So, we have here given dry densities for soil A and soil B. And you have here given 30%, no? S degree of saturation. The water table is 2-meter depth. So, naakay water diri portion, this one. So, naakay water diri, no? And G sub S, or the specific gravity of the soil, is 2.7 for both soil. For both soil na siya. Yes, for both soils. So, to compute for the total stress at P, we have here given, ato sa ning isa-isahon, no? We have here given, S is equal to 30%, and GS is 2.7. So, we remember to use the formula, diba? To compute for the total stress at point P, ang imong gamiton ani is not the dry density of the soil, but it should be the moist density of the soil ang imong gamiton diri. Since amatay given nga dry density, so ato ni siyang gamiton, no? So remember this formula, di ba? This G sub S times this is the specific gravity times the water content is equal to degree of saturation times the void ratio. But remember the formula for the dry unit weight is actually equal to this, to G sub S 1 plus E. Diba? This one kani. So that if you try to look for E, okay. Natay given nga dry density, naatay given nga specific gravity, unit weight of water, okay. Pero wala tay void ratio. And okay, from this one, we try to find the E, no? That is, this is equal to this is equal to this kani siya, G sub S gamma W dry density minus, or dry unit weight minus 1, which is the same ani. To find for the E. So, naanatay E lugar. Naanatay E, no? But, remember also that the total stress at P, the unit weight, no? or the moist unit weight is actually equal to, or the dry density is actually also equal to the moist density or unit weight. I mean, the dry unit weight is equal to the moist unit weight 1 plus water content, no? So, ano siya? Gikan atong ganina, we'll try to find, so makuha na to ang aning diri, makuha na to ni siyang water content. Because water content is unknown man. So, pag makuha na tong water content diri, gamito na po na to ani diri nga formula to get the moist unit weight or wet unit weight na gets ninyo. I hope you get the kuan. So, gikan ana, we have given here, aside from this given, we have the unit weight for soil A equal to 17 kilonewton per meter cube, and the dry unit weight of soil B is equal to 18 kilonewton per meter cube. Dry density meaning dry unit weight ni siya, because the unit is kilonewton per cubic meter. No? But kung ang density ni mo diri is kilogram per cubic meter, ay imong unit diri is kilogram per cubic meter, that is density. But this one, this is dry unit weight. And this one, this is dry. Kay basin maglibog mo, unit weight. So from here, to get the void ratio, that is dry unit weight is equal to this as unit weight of water 1 plus E, diba? So at point P, the dry unit weight is 17 is equal to, given G sub S, this is 2.7 times unit weight of concrete, 9.81 kilonewton per cubic meter, 1 plus E, diba? So, what is E? Makuha nimo ang E ani. Pag makuha nimo ang E ani, proceed to this formula. G sub S, unit weight, ay water content, S E, diba? Remember this formula. Because we are after of the water content. So, to get the water content, substitute the value. This is given 2.7 times the water content, which is we are going to find. Saturated unit weight, degree of saturation is 30%, so that is 0.3. And E, which is makuha ni mo diri, di ba? Kuha ni mo diri ang E. Substitute ang E diri. Then we get the water content. Makuha na to ang water content diha. Dayon, pag makuha na to ang water content diha, proceed to this formula. The dry unit weight is equal to moist unit weight 1 plus moisture content. Since nakuha ni mong moisture content diri, then naa kay given nga dry unit weight of soil A and B, then you will get the moist unit weight. Gani, which is moy atong at A. Kay mo manggoy gamito na to sa, since naman kay water diri, meaning ang imong B, this should be gamma saturated na. Di na gamma moist. In this part, dapat moist unit weight imong gamiton to get the stress, not the dry unit weight. So that is why atong gikuha sa ang moist unit weight, no? So following this procedure or this flow of solution, you will get the wet unit weight, which is equal to 18.606 kilonewton per cubic meter. So that the total stress at P is equal to, this is equal, no? not minus. Kato pong ganina, this should be equal, not minus. Kan equal ni siya. So, kindly solve again, no? Solve again this example para ma-compare ninyo para makuha ninyo ni siya. Saan pagkuha ning wet unit weight. Then, so that the total stress at P is the wet unit weight times the height, 2 meters. So, nanatay value for the wet unit weight at P. But the pore water pressure at P, since naman diri ang water table, the pore water pressure is actually equal to 0. So that the effective stress is total stress minus the pore water pressure. Still, the answer that the effective stress at P, at point P, is 36.12 kilonewton per square meter. No? This is for point P. No? So now we move on to the effective stress at point O. Mura gihapon to siya actual nga procedure, but this time we should find the gamma sat, so that mo ni atong gamiton to get the stress, the effective stress at O, no? So naa kay pore water pressure diri. So still again, no, the effective stress is equal to total stress minus the pore water pressure, no? You proceed. So the total stress at O is actually equal to, actually the same procedure, no? This should be equal, not minus. The same. You use this one, but to be able to use this one, dapat gamiton pa niyo na siya. This is actually from, which I discussed ganina, that is GS gamma 1 plus E, which we discussed, no, sa atong previous nga kuan, volume weight relationship, sa atong previous nga topic, di ba? This one, kani siya. Ikani siya ani. So first, you have to find the value of E, the value of the water content from this, no? So pag human ani, gamit ninyo ni siya, dayon solve for the water content, which is equal to 0.17 or 17%. So try to answer again, no, the example kani siya, so that ma-compare niyo. Dili na nato ni siya like further discuss, and I mean kana bitang like mano-mano gyud og solve, but kuan lang, concept lang akong ihatag, no? So that the wet unit weight is equal to, pareha lagi hapon, no? This is equal. So nakuha na nimo ang water content, proceed ka sa dry unit weight is actually equal to the GS unit weight of water 1 plus nagamit na to ganina. Is unit weight of wet unit weight of the soil 1 plus water content, no? So that the moist unit weight is actually equal to dry density times 1 plus water content, which is this one, this concept. So gikan sa water content nga inyong nakuha, which is 17%, then dry unit weight is actually given 18 kilonewton per cubic meter from the figure, no? 18. So times niyo siya, then you'll get this value of the wet unit weight of the soil at B, soil B. So that to find the vertical stress, to find the the total stress at O is equal to, this is not minus, this is equal to 36.12, which is the weight of the soil. Itong ganina, 36 point, this one, 36.12, no, this is from the soil A. This is soil A, this is from soil A. Kay ato man siyang i-account kay naman diri ang O. Then you have to consider the soil A and soil B. Not soil B only. Soil A and soil B. No? Kay naaman siya diri. So this is soil A, the stress at soil A which we computed earlier, plus the computed wet unit weight times the height of soil B. So this is soil B. So mo ni siya ang total stress at O. But remember, the effective stress is equal to total stress minus pore water pressure. So mo lang ni siya atong nakuha. We have still to compute the pore water pressure, which is from here, from the figure, pore water pressure, since naman kay water content diri, this is unit weight of water times 3, the height, no? To O. So mo nang 3 times 9.81, 29.43. So that effective stress at O is equal to total stress minus the pore water pressure. So this is the effective stress at O. Alright. Hangak ba? Try to understand this one. This is the same concept with earlier example, no? We have actually dali lang ni siya. Okay, try to understand this one. Effective stress. Determine the neutral and effective stress at depth of 16 meters below the ground. Where is the 16 meters below the ground? So we have here the 16 meters, no? Naadire because this is 3 plus 13. This is 16, no? So 16 meters. So at this point, no? Following the, at the ground level for the following conditions, we have the water table. So naakay water table, 3 meter below the ground level. G, or the specific unit weight, so atong ikuan ha, atong ilista. Specific unit weight, specific gravity is 2.68. The void ratio is 0.72. Average water content of the soil is equal to 8% or 0.08. No? This is the water content. We are after of effective stress, no, at depth of 16 meters, neutral and effective stress. Neutral pressure, I think this is the pore water pressure. So first is, muna ni siya ang given. It's the given. Then, we'll try to find the moist unit weight of the soil. So to find the moist unit weight is actually equal to, remember this formula, this is G as unit weight of water plus G as water content, G as unit weight of water, 1 plus E, di ba? As I discussed this one sa una, this is due to the soil mass, this one is due to the water. So actually the same na ni siya ani. This is the same with this formula. If you try to kanang tan-aw ninyo siya, this is the same. So that substitute the values, no? Substitute the values. This is 2.68, the specific gravity times 1.08, that is 1 plus 8% of water. 1.08, then 1 plus the void ratio times the unit weight of water. So this is the moist unit weight of the soil for this soil, this one. So to get the saturated unit weight of this soil, kay kani saturated man ka, pili kani dapat imong gamiton diri is moist unit weight. Pero pag abot diri, they should be saturated unit weight because na naman kay tubig, no? Or water. And the saturated unit weight formula is this formula. The specific gravity plus E over 1 plus E times the unit weight of the water. So substitute the value from the given values. So this is the saturated unit weight. Then to get the total pressure at depth 16 is actually equal to moist unit weight. So 3 times 16.51 plus 13 times 19.39, no? This is height, no? This is gamma moist. This is gamma sat. This 19.39, and this is the height, no? At A, HA, and 13 H kaning portion, say HB. This is the total pressure or stress for the neutral pressure at this depth, which is caused by water, or the pore water pressure, is actually equal to 13. Why 13? Because naraman diri ang groundwater table. So from here, from this to this, because we are after of this point, the effective stress at this point. So manang 9.81 times 13, this is the value. So that the total, the effective stress at 16 meters below the ground level is total stress minus the pore water pressure, which is 301.6 minus the 127.5. So this is the effective stress answer. So try to answer again so that it will be mastered, no, by the computation. So the important kana bitang attack, saan yung pag-attack sa problem is that you list the koan kanang the given, then try to find the right equation for the specific problem, no? Right equation for this, like the kining equation or gamma sat ng equation, no? You have to list down the formulas, no, so that makuha ninyo ang what is asked in the problem. Then so this is the pressure distribution. This is distribution from this example, no, this is actually the distribution. So you have here the figure, yes, the representation. So from 3 meters, we have 49.53 all pressures in. Okay. 49.53, this is equal to, this is gikan na siya ana sa, this one is gikan sa 16.5351 times 3 meters. Because, mo man siya ang moist unit weight ani nga diri nga level sa soil. So, mo ni siyang kani 49.53. Then, the stress, no? This one, the 264.16, gikan na siya na sa, I have an calculator. I think that is gikan sa 13 times 4. That is 13 times 19.39. Alright. Plus times 16. 264. This 264 here, this is from 16.51 times 16 meters. As you can see, it is very proportional, or like triangle gid siya. And plus 37.44, 301.6. No? So this part here, kani siya. The total of this one is actually equal to 301.6 kPa, which is gikan ani this one kani 301 point this one 300.6, and the pore water pressure is 127.5. the pore water, this one is the 13 times 9.81. So that the effective stress is this representation. No? This is the effective stress. This portion is 301.6 minus 127.5. This is the answer. Ano siya ang effective stress? 174.1 kPa. Right? Stop and continue for another video lecture.